Okay, we're going to look at the sum of geometric series. So we consider writing S of n, the sum of the first n terms, as a plus ar plus dot dot dot, all the way to the last term, which is ar to the n minus 1. And similar to the arithmetic, I'll do a brief proof as how to get the formula. And it goes like this. If I multiply all these terms by the common ratio r to get r times Sn, well, the a goes to ar, I'm going to write it under here. The ar goes to ar squared, and then we'll go under that one, and so on. And we'll still end up with the ar to the n minus 1, and then this term, when I multiply by another r, gives me ar to the n. What happens is, all these middle terms repeat, so if I subtract one line from the other, all those middle terms are going to cancel out. It doesn't matter which way around I do it. If I do 1 minus 2 to get Sn minus r Sn, all I'm left with is a minus ar to the n. I can factorise to get Sn bracket 1 minus r equals a bracket 1 minus r to the n. So Sn equals a bracket 1 minus r to the power n, all over 1 minus r. If I'd done it the other way around, done equation 2 minus 1, I would have got a bracket r to the n minus 1 over r minus 1. It's exactly the same. If I times everything by minus 1, this is what I get. We tend to use this first version here if r is an ordinary fraction, and we tend to use this second one here if r is a bigger number, just so that we're not dealing with negative values if we can afford it. So if r is like 0 point something, that would make this positive and that positive. If r is 1 point something, 2 point something, I'd use this version. So let's have a look at a few examples then. So I'm given 25 plus 40 plus 64 plus so on and so forth, and we're asked for the sum of the first 16 terms. So a equals 25, r equals 40 over 25, 8 over 5, 1.6. 16 equals a r to the 16 minus 1. I quote this one because r is bigger than 1 over r minus 1. So 25 bracket 1.6 to the power 16 minus 1 over 1.6 minus 1 equals, and then just press buttons and get your fraction button. 25 bracket 1.6 power 16 little arrow to do your minus 1 bracket, and then over 1.6 minus 1. I know I can work out the denominator myself. It's nice to type in exactly as it is there, and I get, gosh, 76,819.7 something something, and so I could round it off to 0.8 or 0.77 or whatever's like that. So it's a rounding off at the end there. And that's all there is to it. Example 2. As for the sum of the first 10 when they give us the 5th term and the 8th term. I was hoping that I would have done one where they give us the 5th term and the sum of the first 8, but all it is these are our terms, and so I've got to do what I did in the previous lesson, find a, find r. So I know that u8 over u to the u5 will be ar to the 7 over ar to the 4, and give me r cubed. And if I do minus 16 over 9 divided by 48 and cube root it, that's my answer. So minus 16 divided by 9 and over 48 equals minus 1 over 27. So r will equal minus a third. So I can then stick that into either one of these ones. Ar to the 4 equals 48. So a will equal 48 divided by bracket minus 1 divided by 3 to the power, which is 3, 8, 8, 8. Now I've got what r is, now I've got it. A is, I can say S10 is a bracket, I would use the 1 minus r to the 10 over 1 minus r, so I'm not dealing with minus values where I can avoid it. So 3, 8, 8, 8. 1 minus, I've got to be careful with my brackets when I use my calculator. 1 minus minus a third will be bigger than 1. And then press buttons. 3, 8, 8, 8, bracket, 1 minus, bracket, minus 1 over 3, to the power 10, little arrow close bracket, over 1. That's 1 over 3. And I get 2915.9, I can round it off to 2916.0, 2915.95, whatever the answer is that they want as a degree of accuracy. So it's just button pressing at the end. And last one, similar to before, they want, it'll probably be a logs question again, because they'll want a value for k. So our series goes 1250 plus 750 plus 450 and so on. We want where the sum is just going beyond 3124. So I'm going to put it equal to 3124, solve for k, and then whatever that value is, round it up. So as before, it's nice to state a equals 1250, r is 750 over 1250, which I think is 3 over 5, 0.6. And then that's what I'm going to do for, because it's less than 1, I'm going to use 1 minus r to the k, or 1 minus r, and then stick my values in. So I'm going to stick 3124 equals 1250 minus 0.6 to the k, 1 minus 0.6. So I can do some cross multiply, times by 0.4, divide by 1250 equals 3124 times 0.4 equals, divide by 1250 equals, oh gosh, just shy of 1, 3124 over 3125. So when I do 0.6 to the k, there's 1 minus that, I get 1 over 3125. Take logs. So k log 0.6 equals log of 1 over 3125, and k is log of that over log of that. So press my run button, 1 divided by 3125 close brackets, divided by when 0.6 close brackets equals 15.7. There's no minus 1 in this formula, so all I have to do is say that k is the 16th. Take that value and round it up. And that's all there is to it.